today's lesson, okay, there is graphing involved. So for the homework, you're going to want to grab graph paper if you don't have graph paper already, okay? And you are welcome to mine. It's the top shelf right over there. But they are going to ask you a question like this first question you see here. Hey, put that away. It says, what is the graph of the function rule y equals negative 2x plus 1? Okay, so we're just trying to graph that equation. Essentially, what you need to do is make a t-chart. Now, I set up the t-chart in a little more detail. In the future, you may just do it as a t-chart. You know what I mean by a t-chart, right? You can just do this, where it's the x and the y. You don't have to do all the stuff in between for me, and you don't have to do the point itself right there if you're comfortable with just a t-chart, okay? But I'm going to show you this way just so that you know where I'm getting things from and it makes sense. Okay, here we go. Typically, on something like this, because sometimes negative numbers will change things, your general setup for a problem like this is to use the numbers -2, -1, 0, 1, and 2, okay? If I don't tell you what numbers to pick, use those numbers every time, okay? All right, if we're plugging those numbers in, basically what we're saying is we're going to plug in for x, okay, our x value. We're going to plug that in right here in the equation itself, okay? The red goes in the red's location. So if I'm plugging this in, you can forget about y equals. You don't need to write the y equals in between. And really, you guys don't have to do this part of it in the future at all. I want you to do it with me right now just so you see where we're plugging things in. But you may do a t-chart, okay? Here it is. You would do negative, and that's not a pen, that's a highlighter. Hold on. -2, and here's where you'll put your x value times -2 plus 1, okay? What is -2 times -2? 4, positive 4, right? A negative times a negative is a positive. So a positive 4 plus 1 is what? 5. So your point that you're going to plot is -2, 5. Okay? Then we do it for the second one. So it's -2 times what? The -1 plus 1. Okay, so the only thing that's changing every time is that red number. It's our x value, okay? -2 times -1 is 2, plus 1 is 3. So -1, 3 is your point.
So you're just plugging in the x from that side of the...
Yep, that left column is just getting plugged in right here, okay? All right, next one. You have -2 times 0, your x value, plus 1. What's -2 times 0? 0 plus 1? 1. Okay, so 0, 1 is your point. Next one. -2 times 1 plus 1. What's -2 times 1? -2 plus 1 is -1. Right? -2 times 1 is a -2, and then you're adding 1. So you're going to the right one. All right, last one. -2 times 2. Oops, I didn't switch colors, sorry. Plus 1. So -2 times 2 is -4, right? -4 plus 1 is -3. Okay? So we are going to graph that using these points. So -2, 5. And here's where you need to make sure that you're good with this graphing stuff, okay? The x-axis is the horizontal. The y-axis is the vertical. You need to fill in your x first, okay? So left and right goes first, and then up and down. So if I'm -2, 5, I'm going 2 to the left, and then 5 up. Okay? So 2 to the left, 5 up would be this point right here. Okay? Then we plot the next one, -1, 3. So 1 to the left, 1, 2, 3 up would be that point there. Then 0, 1. So 0 left and right, 1 up. Then 1, -1. So 1 to the right, 1 down. And then 2, -3. Like that. So you get all these points, okay? Now, what you need to do with that, hold on, I got to figure out where my ruler went. There we go. You need to use a straight edge on this stuff. And I don't care if that's the edge of a piece of paper or if you borrow my straight edges while you're here, that's fine. You can borrow them free of charge. You don't need to pay me $1. But you need to use a straight edge. I can tell if you freehand a line, and I will not give you credit if you freehand a line, okay? You have to use a ruler, a protractor, something straight. The edge of your binder, I don't care what it is, I want straight lines, okay? The whole point is, if your line isn't straight, then you can't tell me what any other answer down the road would be. But if the line is straight, you have all your answers in that line, okay? So if you want a straight edge, you're welcome to borrow one. They're in the second drawer down, or just use the edge of a binder or something. But your line should look something like this. Okay? Any questions on that? So you're literally taking -2, -1, 0, 1, and 2, plugging it in, and seeing what you get for your y, and then plotting that xy, xy, xy. Okay? Good? All right. 2 little asterisks for you here. You need to make sure of these 2 things when you are doing graphing stuff. First of all, if all the data that you're using is positive, the only quadrant you need to work in is the first quadrant. So if you're doing that, you are welcome to just make your own graphs or print some other graphs up. The ones that I have are all 4 quadrants. But if everything's positive, you're not going to use the other 3 quadrants. You're only going to use quadrant 1, okay? And you're welcome to do those on those graphs still. Just know that you won't go outside of that first quadrant then, okay? So if everything's positive, you're in the first quadrant. The second thing is, and we've talked about this, but you have to make sure that you count by a consistent number. You can't just say, oh, I have the point 1, 7, and 3, 13, so I'm going to count 0, 7, 13 for my y's. That doesn't make sense, okay? You have to jump up the same amount, and you have to go across the same amount every time. Now, this number can be different than this number. Like I can count by 1s on my x-axis, 1, 2, 3, 4, and count by 5s on my y-axis, that's fine. But on an axis by itself, it has to count by a consistent number. So if you're counting by 5s, count by 5s the whole way. If you're counting by 2s, count by 2s the whole way. Good with that? Okay. All right, so let's look at example 2 here. You are given this equation, W equals 146C plus 30,000. It says W is the total weight in pounds of a truck that carries C cubic feet of concrete. Okay, so C is concrete, W is the weight of the truck. I want to know if the capacity of the truck is 200 cubic feet. What does capacity mean? How much it can hold, okay? So if the most the truck can hold is 200 cubic feet, what is a reasonable graph, okay? So let's think about that. We have this C, this amount of concrete that we're plugging in to an equation. What's the least amount of concrete a truck can hold? What? 0, right? Maybe it's holding nothing. Who was that? They come in the wrong room?
I did that last time.
Hate it when that happens, huh? Okay, so a truck could hold 0 pounds, cubic pounds of concrete, right? So that's where we're going to start with this. Can you have negative amounts of concrete? No. So you're not going to use any negatives, so we're only going to be in that first quadrant on this one. What's the most concrete this truck can hold? 200, right? We said the capacity is 200 cubic feet. So that's the most. So our range is going to go anywhere from 0 to 200. So we just have to figure out what are some good numbers to put in between there for us to get a nice graph. Okay? Right. So this would work out beautifully if we count by 50, right? So 0, 50, 100, 150. And I'm going to apologize right now because I should have given you more space in your CW and even in the rest of it. So my apologies that you might go over the lines a little bit on these, but we're just going to zoom way in so I don't. Okay, so if this is the setup, we're going to take this C values, all of the C values, and plug them into our equation, okay? So it's going to be 146 times what? Times 0 plus 30,000. Well, when you plug that in, 146 times 0 is 0. When we add the 30,000, it's 30,000. So my point is 0, 30,000. Okay? Oh, you'll see. That's what I'm saying. You got to be real specific with your numbers, right? Okay, second one, 146 times what? 50. Plug in your X value of 50 plus 30,000. Okay, when you plug that in, your X value is 50, or your C value, in this case, is 50. Your W, your weight, is 37,300. And I don't expect you to do that in your head. Your calculator will do that just fine. Okay, then 100. Same thing. 146 times 100 plus 30,000. You get 100. And that comes out to 44,600. Okay, that's what I'm saying. In the future, I'm not. I worked it all out already. Don't think I can do that in my head. I cannot. No. In the future, you don't have to do this whole part, right? You just have to give me the X and the Y. I don't need to see all of it, so you don't have to write it all out. But for now, we're going to do it just so we know what we're looking at. Okay, next one would be 146 times 150 plus 30,000. Okay, that leaves us with our C value is 150, and our W is 51,900. Okay, and then last one, you have 146 times 200 plus 30,000, and that comes out to 259,200. Those are big numbers. So here's the deal with that. You have those numbers that need to be graphed. Okay? They're going to get graphed on this chart here. Actually, we'll leave this up here so you can see the variables. So we were talking about two different things. What is going to go on our x-axis right now? Is what? Okay, variable-wise. What's the variable going to be on the x-axis? The capacity, which was in cubic feet, right? So how much concrete in cubic feet? So we're going to write concrete in cubic feet. So feet cubed is what we're talking about. Okay? What's going to be our y-axis right now? What does W represent? The weight of the truck, right? Oh, I have my ruler up there. Look, it wants to connect to my ruler. That's funny. You can't see my ruler. I promise it's trying to connect to my ruler. Okay, so our W is going to be the weight of the truck, and that's going to be in pounds. Okay? Okay, so now here's your job. You have to figure out what makes sense for you to count by in both of these. So if you look at just your X values right now, okay, all of these guys, you have 0, 50, 100, 150, did I what?
Yeah.
Okay. And 200. Okay, you have all those numbers. We have, if you look down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different places that we could put a number, right? This is 1, 2, 3, 4, 5 numbers that we're using. So here are your options, okay? You could count by 50s. And then each one is where you're going to plot vertically from there. That's totally fine. The other option is you could count by something smaller than that, so it spreads it out a little more. If you were going to count by something smaller, what would it be? 10s wouldn't fit if we had to get all the way to 200. 25 would fit, okay? So you could count by 25 or you could count by 50. I'm going to count by 25 merely for the fact that things don't end up on top of each other then, okay? But it would not be wrong to count by 50s. So I'm going to go 25, 50, 75, 100, 125, 150, 175, 200. Sorry, that's kind of difficult to see. Okay? Good on that? They're just walking. You don't need to watch them. Just walking. Okay, then we have to deal with the weight of the truck. And this one maybe is a little more challenging to come up with a number that you feel like makes sense. But you want to keep it as simple as possible. Okay, so I'm going from as low as 30,000 up to 60,000. What would you like to count by? There's not a wrong answer here. Well, there are wrong answers, but there's a lot of right answers. Okay, what would you think to count by?
Is that one?
Yeah, it's just not a pretty 150. What do you think? What would you want to count by here? Just an easy number to jump up each time. 10,000? Okay. I would count by 10,000s. Here's the thing. You cannot start at 30,000. Okay. I can't put 30,000 right here unless I'm going to count by 30,000s. Okay. We don't want to start at 30,000 unless that's what we're counting by. And if we count at 30,000s, we're going to have a teeny little tight graph. Okay, so I'm going to count by 10,000s. I'm going to make this 10,000. I'm going to make this 20, 30, 40, 50, and 60. Okay, why am I stopping at 60? Because there's nothing beyond 60, right? The highest we went is 59.2. Okay, so let's plot some points here. The point 0, 30,000, that's an easy one because it falls perfectly on a crossbar. That would be this point right here. Okay, 0, 30,000. Your second point gets a little hairier. That goes 50, so we're going to be somewhere on this line here, right? So you go to 50. And then you go up to 37,300. Is that going to be closer to the 30 or the 40? The 40, okay? So from 50, 37.3 might be somewhere right around there. Okay, then we're going to go to the next one. 144,006. So 100 is here. 44,006 is almost right in the middle of that one, just a teeny bit below middle. Sorry, it's not great on my iPad. So that would be there. Then we go 150,000, and then it's 51.9. So it's going to be closer to the 50 than the 60. Maybe right around there. And then the last one is 259,200, which is going to be really close to the 60. Okay? Now here's my question for you. Do we want to draw a line in? Could the truck have a different amount of concrete and then a different weight? Yes, it can, right?
Could be like decimal.
Right. It could be a fraction, it could be a decimal, it could be something different. However, what can it not go over? What's the max capacity? 200. So your graph of this, you're going to draw a straight line in, but you're going to stop at the 200. So it's going to look something like this. Sorry, my graph didn't quite hit that. Apparently this one should have been a little lower. But you don't want to go past this 200 point. Okay, if you go past that, you're over capacity. So your graph would look just like that. Any questions on that whole process? Okay. Next. Let's put the ruler away. There we go. Okay, two things to note for this next little piece. You have a continuous graph versus a discrete graph, okay? A continuous graph means it can fall anywhere on the graph itself, okay? So a continuous graph will look something potentially like this. In other words, all of the points are there, so we can put a line through it. Whereas a discrete graph, if we are graphing a discrete graph, you'll have very specific points, and those will be the only things that are true from your picture. So discrete graphs don't have a line drawn in. Continuous graphs do have a line drawn in, okay? All right, so here's what we're going to do. Example 3 here, it says the amount of milk used to make cheese and the price the cheese is sold at are 1 gallon of milk makes 16 ounces of cheddar cheese, and then each wheel of cheese costs $9. Okay, so we're going to look at this from two different perspectives. We're going to look at it from the gallons of milk related to the ounces of cheese. That's this one. And then the amount of money related to the number of wheels it will make, okay? You need to start with this chart, and I should have just put this chart in, but I didn't. So this will be given to you, okay? You have M and W, and I'm going to give you the numbers. So this goes 0, 1, 2, 3, and 4. This goes 0, 16, 32, 48, and 64. All right. So if we're going to plot these, we got to figure out what makes sense here in terms of where our variables are and how we represent them. So M, we set up here, is gallons of milk. So this is going to be gallons. And W is ounces of cheese. So make sure you label these, gallons of milk and ounces of cheese. And then we're just going to plot them. So we got to figure out, what are we going to count by? What do you want to count by on gallons? Where are your gallons? Count by ones, right? This is 0, 1, 2, 3, 4. Count by ones. So here's 0, 1, 2, 3, and 4. Okay, if you wanted to space it out more, you could count by a half, just so you have space in between, but you don't need to. Then we have ounces of cheese. What do you want to count by there? Let's see, if you count by 8, 16, 24, 32. You could count by 8. 8 would be a really good number to count by. Why did you come up with 8? Because they're all multiples of 8. 8 is a really good number. I don't expect you to be able to come up with that because it might be hard to see that just looking at it for a lot of people. But if you can come up with 8, your graph's going to be beautiful. Okay? If you don't come up with 8, what else could you count by here? You have to get up to 64. 1 wouldn't work. Tens, maybe? You can count by tens, okay? So let's just count by tens, assuming that not everyone is going to figure it out as quickly as Brandon did. Okay, so if we plot our points, we have 0, 0. We have 1, 16. We have 2, 32. 3, 48. And 4, 64. Okay, now here's my question. Is this a continuous graph or a discrete graph? If we're talking ounces of cheese and gallons of milk, can you have 1.5 ounces of cheese? Can you have 3.2 ounces of cheese? You can, right? You don't have to have exact ounces of cheese in everything you do. So this would actually be a continuous graph. So you take your straight edge and you would draw that line in. Okay, that would be continuous. How are we doing so far? Okay. Let's look at this one then. Now we're talking amount of money and number of wheels. And this will be given to you, and I'm going to flip this around because the number of wheels affects the amount of money. So we're going to make N your X and A your Y. Okay? Here are your numbers. 0, 0, 1, 9, 2, 18, 3, 27, and 4, 36. Okay? All right, we said A is the amount of money, and that's our Y here, right? This N is our X, A is our Y. So this is going to be amount of money. What's going to go on the bottom? My X-axis, the number of wheels. Okay, so we're talking wheels of cheese here, okay? What do we want to count by on our X-axis? Count by ones, right? We're going from 0 to 4. So let's just count by ones. 0, 1, 2, 3, 4. That's all the farther you have to go. Then amount of money. What could we count by there?
9.
You can count by 9. Okay. I'm going to count just because people won't always see that there is a multiple of 9 for everyone. I'm going to count by 5s. Okay. Just so you're seeing it a different way. 5, 10, 15, 20, 25, 30, 35, and 40. Okay, so we plot those. 0, 0, 1, 9, 2, 18, 3, 27, and 4, 36. Okay. Discrete or continuous? Think about what you're doing. Do you know what a wheel of cheese is? It's those like circle, cylinder-ish. It's a wheel of cheese. It looks like a wheel, like you could turn it on its side and you could roll it down the road, right? You know what a wheel of cheese is?
Oh, yeah.
You with me on that? Okay. The question is, can you have 1.2 wheels of cheese that you're selling in the store? No, you buy it by the wheel, right? I have 1 wheel of cheese or 2 wheels of cheese. You don't go in and be like, oh, you know what? My family's not going to eat all that cheese. I'm just going to cut this little corner off of it and take that, okay? We don't do that in the store. Therefore, this one is a discrete graph. We're not going to draw the lines in because you can only buy whole wheels, okay? Good on that? Okay. Back at it. These last 2, okay? Oh, low battery. Don't die on me. These last 2, you're going to use the same rule I told you at the beginning. There's 5 numbers that are good numbers to plug in when you're doing just a generic graph like this, where it's not a real world type of problem, okay? Do you remember what those 5 numbers were? Right. Okay, so you're going to plug in those numbers in this setup. So if I plug in to this graph, -2, I'm going to do y equals the absolute value of -2 minus 4. What is the absolute value of -2? A positive 2, right? Absolute value always makes it positive. So we're doing 2 minus 4, which is -2. Okay, so when you plug in a -2, you get out a -2. Okay? Plug in a -1. Y equals the absolute value of -1 minus 4. What's the absolute value of -1? 1. What's 1 minus 4? -3. So that one's going to go here, -3. Okay? Plug in 0. I'm not going to write the rest of these down. We're just going to talk through them. If I plug in a 0 here, what's the absolute value of 0? Minus 4 is -4. Okay? What's the absolute value of 1? 1 minus 4 is -3, right? So the absolute value of 1 is still 1, just like the absolute value of -1 was 1, right? It always makes it positive. So this is -3. And then 2, the absolute value of 2 is 2. 2 minus 4 is -2. So if I plot those, I end up with this graph. -2, -2. -1, -3. 0, -4. 1, -3. And 2, -2. Okay, and these ones, if it's just the generic setup here, you're going to draw, that's not showing up for you, huh? I don't know what I just did. Sorry. Hopefully it didn't mess up the video. Okay, so you're going to take your straight edge and you're going to draw those lines in. Okay, now here's the trick. Every time there is absolute value in a problem, it's going to be a V-shaped graph. Okay, so if you see the absolute value bars, you should get a V in your graph. Questions on that? Okay, let's look at this one then. Last one. We're almost there, guys. Almost there. What are the 5 numbers we're going to plug in? Yes, -2, -1, 0, 1, and 2. Okay, so when we plug those in, here's where you got to be a little bit careful. Your equation is x squared, okay? So y equals -2 squared plus 1. What is -2 squared? Positive 4, okay? Just be careful with that. -2 squared is a positive 4 plus 1 is 5. Okay, then you plug it in with -1. -1 squared plus 1. What's -1 squared? 1. 1 plus 1 is 2. What's 0 squared? 0. 0 plus 1 is 1. 1 squared is 1 plus 1 is 2. And then 2 squared is 4, plus 1 is 5. Do you see what happens with your numbers there? 5, 2, 1, 2, 5. Okay? Even though we had negatives and positives. All right, so if we plot those, negative 2, 1, 2, 3, 4, 5 is that point. Negative 1, 2 is that point. 0, 1, 1, 2, and 2, 5. First of all, is that a V? Not really, right? It's more of a U. Because you can't put straight lines through it. They're curved. This is actually called a parabola, which is more of a U-shaped curve. So here's what you need to know. Whenever there's an x squared in a problem, your graph is going to be a parabola or a U-shaped graph. Okay, so absolute value on the left gives you a V-shaped. X squared gives you a U-shaped. That's how you can always check your work. If it's not U-shaped on an x squared problem, something's wrong. Okay? Any questions on that?
No.